I believe this paper deserves a mention. The reason being that it proposes an iterative training algorithm, which is called as iterative reasoning preference optimization, for improving chain of thought based reasoning task performance in LLMs. In each iterations, these researchers have generated multiple responses and have built preference pairs based on the correctness of their final answers, and then use a modified direct preference optimization or DPO loss with an additional NLL term for training. Their method does not require human in the loop or extra training data and remains simple and efficient to implement. And that is why I think this might be in practice very soon, and we might be employing it in order to create our data set. The experimental results are quite promising. They show large improvements on GMS 8K, Math, and ARC challenge over various baselines using the same base model and training data. These results indicate the effectiveness of their recipe of iterative training in improving the reasoning capabilities of large language models. The thing is that the traditional methods fail to improve reasoning tasks using iterative optimization. Reasoning tasks remain challenging despite advances in language models. That is where this paper by Meta introduces iterative reasoning preference optimization that iteratively generates chain of thought candidates, constructs preference pairs based on correct answers. And as I mentioned, it uses modified DPO plus NLL. If you don't know what NLL is, NLL stands for negative log likelihood. It is a measure of a model's performance, and the lower the NLL, the better the model is performing. NLL is a proxy for maximum likelihood estimation, which is a general statistical concept. This concept is used for classification and regression as well as estimating variances or other parameters. Now, preference optimization has proven to give large gains when aligning pre-trained language models to human requirements compared to supervised fine-tuning alone. Offline methods such as DPO are becoming more popular for their simplicity and efficiency. Recent results have shown that iterative applications of such an offline procedure is beneficial, and the updated model is used to construct new preference relations that are more informative and hence improve results further. These methods include iterative DPO, self-rewarding LLMs, and few others. Common to these approaches is that they have been shown to perform well on general instruction tuning tasks, but they either make only moderate gains or even decrease the performance on standard reasoning tasks. While other kinds of iterative training methods have been applied successfully to reasoning, particularly involving iteration of supervised fine tuning such as star, rest, and V star, using preference optimization to train the generative reasoning model is not applied in this method. And that is why this new approach of iterative preference optimization to reasoning tasks with a particular focus on chain of thought reasoning is quite important. On each iteration, they have sample multiple chain of thought reasoning steps and final answers over training prompts, and then construct preference pairs such that pair winners have correct answers and pair losers have wrong answers. They then train a variant of DPO that includes a negative log likelihood or NLL loss term for the pair winners, which also proves crucial for performance. Given the newly trained model, they then iterate the procedure by generating new pairs and training again. Starting from the previously trained model, they find that reasoning performance improves over multiple iterations until it eventually saturates. And you can see that in that figure which is on your screen, as their iterative preference optimization method consists of two steps. First, chain of thought and answer generation, where training prompts are used to generate candidate reasoning steps and answers from model M, and then the answers are evaluated for correctness by a given reward model. In the second step, preference optimization is employed, where preference pairs are selected from the generated data which are used for training via DPO plus NLL objective, resulting in model MT plus 1. This whole procedure is then iterated, resulting in improved reasoning ability on the next iteration until performance saturates. And as I mentioned earlier, this method has already outperformed number of baselines including SFT or applying standard DPO as well as other baselines from the literature. And you can see in this diagram, which I just described in 2 steps for chain of thought and answer generation plus preference optimization. So all in all, I believe one of the finest paper this month in May, which is, I think things are moving along quite rapidly. So one of the best thing I really loved about is the chain of thought reasoning. Plus, they have experimented with more advanced math problems using the maths data set that is composed of more than 12,000 competition problems. And the test set has 5,000 examples, similar to the GSM 8K dataset. A gold chain of thought solution is provided for each problem, and the gold answers can be matched uniquely to predict the answers from normalization to compute rewards. There are a lot of good things which are scattered throughout this paper. I will drop the link to it in video's description. Read through it, should be a good read. And if you like it, please let me know. And if you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.